Okay, so now that we've covered Porter cipher, we're gonna move on to Nihilist substitution cipher. All right. So like before, we're gonna look at the text here, or the text here. So it says decode this phrase that was encoded using the Nihilist substitution cipher. So that's how you know it's this cipher, right? Nihilist. Now, then it goes on to say with the keyword of Harvard, all right, and the Polybius key of collegiate. So you're gonna have to understand that Polybius key and keyword are two separate things, all right, and they both have different uses. The Polybius key is going to be used for this grid over here, and the keyword is going to work similar to the Porta keyword, where you write it over and over again at the top, all right? So for the keyword, the normal keyword, we just write Harvard. So we just write Harvard over and over and over and over again, all right? And we ran out of space, that's when we stop, all right? So that's the keyword. Now, what we're gonna do now is we're gonna find the Polybius key. What are we gonna use that for? We're gonna start the top left corner of the grid, and we're gonna start writing this Polybius key. So we're gonna write C, O, L. But now, you would probably think, okay, we're gonna write another L, right? No, all right? In this grid, we do not have any duplicate letters, all right? So instead of having two L's, we're gonna skip the other L and then move on to E, and then G, and then I, A, T. And now you would think, oh, okay, so then we skip E again, which is correct, all right? We skip E once again because we already wrote E, so that's a duplicate. Now, what do we do now that we've written the keyword down? Now, what we're gonna do next is we're gonna write the normal alphabet, because that's usually how it works. You write the keyword and then you write the normal alphabet. So we're gonna do the same principle that there are no duplicates. So if we start from A, because we're writing the alphabet now, there's already an A here, so we skip that. So now we go B. Now is there a C here? There's already a C here, so we go to D. And then now there's already an E, so we skip that. We go to F. And there's already a G, so we skip that. So now we go H. There's already an I, so we skip that. And now here's the important thing, the last important thing, is that J and K share the same square, all right? J and K are the same, they share the same one, all right? You can remember that. Now, next, after that, L, we can't write L because it's a duplicate, right? So we go, now we have M, and then we have N, and then we have O, which is already written, so we skip that. P, Q, R, S, now we already wrote T, so we skip that. U, V, W, X, Y, and Z. And if you did it correctly, the entire grid should be perfectly filled out, all right? So now, you might be wondering, what do we do with this? How do we actually use it? What's the point of making this square, right, this grid? Well, now what we're gonna do is, this grid gives us the ability to convert letters into numbers, all right? So, how does it work? The row number is equivalent to the tens digit. The column number is equivalent to the ones digit. What do I mean by this? What this means is that C here, C equals 11 because it's in row 1, column 1. Let's say S. S is in row 4, column 4. So it is S equals 44. What about U? U is in row 4, but it's in column 5. So that means that, oh, wait, I forgot. So yeah, U equals 45. Right? So now we can convert them. Now, hopefully you have an intuition already in what you do. So let's use the first one as an example. We have H as the keyword and 64 as the ciphertext. Now, if we convert H to a number, we're going to get 32. Row 3, column 2, that's 32. So let's write 32 here. Usually you do this in your head though. But let's say it's 32. What you're gonna do now is you're gonna subtract this number from this number, all right? So now, what do? 64 minus 32 is 32. Okay, we got a number now. What do we do with that number? What we're gonna do is we're gonna go back in this table and we're gonna convert that number into a letter, all right? And we're gonna do that. We have 32 here. What is that? What is the tens digit? 3. Ones digit? 2. That means it's in row 3, column 2. Row 3, column 2 is H. Again, it's the same thing. Now, we're gonna move on, all right? Now, what is A, all right? Let's move on to A, all right? So A is 22. So A is 22. And then that means 34 minus 22 is 12. 12. So where is 12? Row 1, column 2. That's O, all right? O. And we're going to keep on doing this. So R is 43. So that's 95 minus 43, which is 52. 52, which is W, all right? So we're going to just keep on doing that. And that's the whole essence of what nihilist is, all right? Just keep on doing that until you finish the entire problem. And then you solved it. Congratulations.